Okay, so for functions and relations, we first need to know how to do a composition of functions with graphs. Okay, so with a graph, how would you do a composition of functions? So we're going to see page 23, the graph. Okay, so we're going to go back into your notes, and it's Unit 4, the beginning. And you have notes on it already, and that's cool, because so do I. So we're both dealing with the same. Now, a composition of functions is actually a function inside of a function. Okay? And it actually looks much more intimidating than it is. And it is one of those things like the first day, if you add two lines together. What do you mean add two lines together? A line goes forever, add another line, same line. Okay? It's not. Now we know that. Well, how are you going to do f of g of 1? Okay? Take a minute. What do you think f of g of 1 would be? So I want you to look at the graph above. You can see where f is. I want f of g of 1. We had a bunch of students in the last class that got it. I didn't even teach it to them, so it is possible. I'm not setting you up. Any takers? Anyone brave enough to speak up in 38 people? That's the bad thing about 38. It actually gets quieter than the 27. Come on. What do you got to lose? Just your dignity. Any guesses? None. Yeah, -6. Okay, you doing all right? I feel a little weird for you right now, I won't lie. I'm just kidding. Okay, so this is how you do it. You look at, to do these, you work from the inside out. So I'm looking at the very inside, what's g of 1? So when x equals 1, right, and this one, remember, this is g, okay? So here's g. So when x equals 1, g is -1. So this turns into f of -1. Because g of 1 is -1. Correct? G of 1 is -1. No? Okay, can I show you again? See, here is my x is 1. Can you see that? Therefore, when x is 1, g is, and we're looking at this graph, g is -1. Okay? So, g of 1 is -1. Now, what's f of -1? So this x gives me the entire y. That y now becomes an x. So what is when x is -1? G is, or sorry, f of -1 is right down here, right? You see it? So you should get -6. Okay. Now, what you kind of have to go through in your mind is, how am I going to get this on my study sheet? Like, what should I do? A little example? Say little steps to myself, right? Because remember, you're not doing that study sheet just for your unit exam. You're doing it for your diploma. So when you do your study sheet, it's like, will I remember this? Like, what could I do to remember this in 5 months? Okay, now let's do one more since I've shown you how to do it. See if you can get g of f of negative 4. Yell it out as soon as you get it. Oops, forgot some brackets here. Yep. So what's f of negative 4? 6. So we are doing g of 6. G of 6 is 4. Okay, so let me talk about that. So we got f of negative 4. So here's negative 4 right here. So I follow it up, and I'm going to hit the f graph, which is at 6. Okay? So that's how f of negative 4 is 6. So now, see how 6 was in the inside? Like, f of negative 4 and 6 are the same thing. So now I'm taking the g of 6. Well, 6 is over here. So what does that fall if I go up? The answer is 4. Okay? So that is how you do composite functions on a graph. So those take a little bit of practice. And there'll be some on your quiz tomorrow. Because if you still don't know how to do them, then you have something nice to study off of after we mark it. Okay, so let's go to page 34 now. And we're going to just talk about like the wording of it, the setup. Now, this is what we have just worked with. And we call that g of f of x. And the way we do them is we start from the inside out. So I will find out f of x. So f of x is inside g of x. That's what that is, and that's what it means. Okay? The other way that this can be written is g of f of x. Now, they're both said the same way, but that's a little circle, a little empty O there. That's not a time sign. But that one, instead of doing from the inside out, we do from the... Since those two mean the same thing, which way would you do it? From the... Come on, you guys, you need to articulate your thoughts here. How would you know those two are the same? What would you write down on a study sheet? Because you're going to forget it in 5 months, guaranteed. How would you do the second one? How would you tell someone, this is how you have to do this kind? You have to do this first. Which do you have to do first? F of x, right? So you would work from right to left. So right to left when it's in that form, or inside out if it is in the other form. They mean the same thing. Left to right in this form mean inside out in this form. This is the stuff you put on study sheets. It is low-level learning. It is memorization. Okay, it's those tools that you need to get through the diploma. And then in 4 to 6 weeks, you will forget all of these little things. So it's kind of like, I need you to know these higher level concepts, but you do have to memorize this useless stuff first, okay? And that useless stuff is in everything we do. But it is not something that we can take for granted that I just know that. I don't have to write that on my study sheet. That's easy. Because in 5 months, you might be going, oh man, I wish I would have wrote that down. So every time you're doing your study sheet, think about what am I going to forget in 5 months? And I bet you'll forget you always read right to left or inside out when you do these. Okay? So we're just going to go down to the whole next page at the bottom. And we're going to start with example 4. Okay, so we have two different functions here. I got f of x and I got g of x. It says, yep. Right, because we do f of x first and then g of x second, right? Okay, yep, that's where I want to be. Okay, so there's my two. Now, I don't like that form, so I always turn it into g of f of x. For some reason, this makes more sense to me because I can see f of x inside g of x. Right? Why? Because f of x is inside g of x. So what I'm going to do is I'm going to take f of x and I'm going to put it inside g of x. Do you see this x here? It's getting replaced here and here. Okay? So I'm taking this entire thing right here, and it is going to go right in there. I am putting f of x inside g of x. So this will be 3 times 2x squared minus 1 minus 4. That is g of f of x. Does that make sense? Now the only little thing is, let's get rid of some brackets, right? So that would be 6x squared minus 3 minus 4, and I can get the minus 3 and the minus 4 together to be 6x squared minus 7. Okay. Now I'm going to get just rid of this right now because I'm doing a new question. So B says take g of x. What does that mean? It means, well, take g of x and put it inside g of x. Okay. Now if you have to, and this does help some students, write out g of x again. G of x equals 3x minus 4. And now do we see that we have to take this and we're going to put it into this. So what I'm going to do is I'm going to go 3 times 3x minus 4 minus 4. Okay. So that is 9x minus 12 minus 4, which is 9x minus 16. That is g of x. So once you know how to do it, they're not that tough. They've actually tried to make this quite complicated, so I've gone through this and I got rid of a lot of stuff. So we're going to actually, on the next page, I want you to kind of draw a line there, because all that stuff above is going to mess with your head a bit, so we got to keep things simple. The challenge to math, it's not making it complicated. It's already complicated enough. It's making this stuff simple. Now, I just want you to write down these two expressions because we need them for this question. I want f of x to equal x squared minus 3, g of x to equal square root x minus 1. Okay, so that's our f of x and g of x we're going to use for these two examples here. X squared minus 3 and square root x minus 11. Okay, now this asked for two things. It asked for f of g of x and g of f of x. So let's do the first one, and I'm just going to rewrite it as f of g of x. Okay, so that helps me, right? Oh, I want g of x inside f of x. So that is going to equal, remember, this is going into here, right? So I always want to substitute with brackets. And we can call this like even h of x, right? Like that's like our new one. So that actually is our function right there. Now, what happens after this gives us some insight of where I'm going, because it's a setup that after I do this, I get x minus 1 minus 3, and I get x minus 4. That's h of x. So the question would be, what is the domain of h of x? Element of the reals, okay? And that's what most people would pick. It's the wrong answer, but most people would pick that one, okay? You just have the guts to say it. Everybody else was thinking it too. So now, I mean, it's a setup. Obviously, I set you up. But that's what kind of a diploma is. It's like a setup. Like, do you know this stuff? I'm going to put this out there, see if you know it. Okay? So I already told you that x isn't in the reals, but let's face it. I see x minus 4. I don't see anything that can't go in there. I'm good with x in the reals. But what was our original function? Our original function was this. So we have to stay true to that one. That one's doing the dictating. Now, can x be in the reals in the step in the box? Does negative 3 work there? No, so x isn't in the reals. So x has to be x minus 1 has to be greater than 0. X has to be greater or equal to 1. Okay? So actually, we can actually write that down here. X is greater or equal to 1. They give us the domain, right? So, and then, like, why? Because you're going to look at this after you go, wait, x minus 4 can be anything, right? Because we have to look right there. Now, here's the real challenge. What would be the range of that function? Obviously, it's not y is in the reals. Like x minus 4, you graph x minus 4, it's a line. Come on, x in the reals, y is in the reals. That's the first thing we ever learned when we were doing these domain and range. They gave you a straight line. It was everything after that that got confusing, right? I get the line. Okay, x in the real line. I get that one. Okay? But now I'm telling you that that line, that isn't the truth anymore because where it came from. What would be the range of that? I mean, if you were to put that function in the box there in your calculator, you would see the domain and range. And let's think about it. Yep. No, it wouldn't be an absolute function. The way you do it is you use your domain to get your range. My domain is anything greater than 1. What if I put 1 in there? What answer would I get? negative 3. I can't go less, so let's put 2 in there. 2 minus 1 is 1. Square root of 1 is like 0.3. 0.3 minus 3 is like negative 2.7, right? Which direction are we going? What's bigger? Negative 2.7 or 3? Negative 2.7. Do you see that? So negative 3 will be the smallest possible number I can get. So we use our domain, we plug it in. And we find that our range would be y is greater or equal to 3. Negative 3, sorry. Okay? So use domain to find the range. You actually plug your domain in. Plug in anything greater than 1. And I think I've told you enough. The diploma loves domain and range questions. Okay? So I'm going to have to inundate you with domain and range. We should talk about it every day since you're going to see it so much. Okay? Now let's do the next one. Let's do g of f of x. Again, the way I think about it, g of f of x. So f of x is inside g of x. Okay, so what's that going to look like? Well, that's going to look like h of x, which is square root x squared minus 3 minus 1. Does that make sense? Now, can I just drop those brackets? Yeah, I can. Why can't I? Because sometimes you can, sometimes you can't. Like, why? Why can I just drop those brackets? True. No coefficient, because if there was, I'd have to multiply it in first. And there's no exponent. Since there is no exponent, like if there was a squared here, I'm not dropping the bracket. And please don't distribute this. Don't make that x to the 4th minus 9 or plus 9. You can't do that. That would be x squared minus 3 times x squared minus 3. Okay? But because there is nothing there or nothing here, if there was a 5 there, I'd have to multiply it in. I'm actually got free reign just to drop my brackets. And then I would get x squared minus 4. Okay? Now, by looking at that equation, what would be my domain? What do we know to even go try and find the domain? What's one thing that I've got to... Greater than equal to 2 will work. And? So I like that one. What else do I need? Some people were saying part of it, I need the x would have to be less than or equal to negative 2. Now, that's not very intuitive for some people. They're like, how did you get that? Okay, well, can I just start from here? And the one thing that I think we can all agree on is that x squared minus 4 has to be greater or equal to 0. Right? Do we all agree with that statement? That thing has to be greater than 0. I can't take the square root of it. So then you just do one little thing, and you just now we're going to do a little algebra. Add 4 to both sides. That x squared has to be greater or equal to 4. Now the confusing thing now is, well, we're supposed to take square root of both sides. Well, if you take square root of both sides, you will get x equals plus or minus, or x is greater than or equal to plus or minus 2. So the crappy thing about this part of algebra is like, so it says x has to be greater than negative 2. And no, actually x is less than negative 2. Like negative 3, negative 4, negative 5, negative 6. So this isn't a true statement. This is, right, x has to be greater. The other one, you're going to actually have to maybe even stop here. And if you get x squared has to be greater or equal to 4, we know that 2, 3, 4, 5, 6 work in there nice. And then we also have to know the negatives. Negative 2, negative 3, negative 4 go with them. So some people find it easier to go here instead of doing that next algebra step. Whatever you're comfortable with, but you have to understand that squaring negatives make them positive. But negative 8 is way smaller than negative 3. And some people still have that 8 is bigger than 3. I've always learned that. You know, the negative though, you know, minus 8 is colder than minus 3. Okay? So, bigger. But the number's bigger, but it's actually, or I should say, the magnitude is bigger, but the direction makes it smaller. Okay? So, now that we have the domain, how will I find the range of this one? I want you to plug your domains in. What kind of values would I be getting? What happens if you plug in 2? What do you get? 0. Okay. If you put in negative 2, you get 0. So we want to find out, like, what is the least value I would get? Or maybe it's the most, the biggest. So by putting in your domain, what do you think the range would be? What answers am I going to get by putting in 2, 3, 4, 5, 6, negative 2, negative 3? Yeah, y is greater or equal to 0. So I think the greatest challenge you'll have today is sitting down and thinking about those domain and ranges. Okay, now this next part, you know, when we calculate, I don't know, this is like probably the longest sentence ever that gives the least amount of information you'd ever need. When we calculate an expression for a composite function, there may be restrictions on the domain or range. Oh, thank you. That little nugget of information. In most cases, the domain and range of the composite function will be different than the domain and the range from the original. Okay? Most cases. And the domain of the composite function cannot be more than the domain of G. So this is probably the most complicated one. How about we just say we stay away from these and just have a really, like on your study sheet, I would have a really good example. Like I think probably the best example of teaching you domain and range would be the first one. Okay, I like this one. It is a very good example of how to do a effigy of x and how to do domain and range. Sometimes all of your notes can be summed up in one really good example. And you can do it tiny. This one I would do 2 examples, would cover the whole unit. The example we did to start with the graph, and this example here. This covers pretty well everything. And you could also put effigy of x, you know, the 2 ways this can be written. Get that in one little place on your study sheet, and this entire concept can be summed up in one little square. And within 5 months, you'll be able to get this out. All right, those two forms mean the same thing. Oh yeah, domain, you get it from this, and you get your range from putting your domain in. Okay? This is really easy to forget stuff. Okay? Because you're not going to use it much throughout the rest of the year or the term. So what happens when you don't use it? You lose it, right? If you ever go to another country for a few months and you pick up the language, and then a year later people go, hey, how do you say this? And you're like, oh man, I used to know how to say that. What does this word mean? And you were saying, you were talking in that language at one time. So why you came back, you weren't using it, so it was memorized. It's the first to go. Okay, so we're doing 7 to 16.